Hi, you are welcome in Arduino learning lecture series. Today we will discuss about ultrasonic sensor and how to interface ultrasonic sensor with Arduino. So let's start this video. We will demonstrate our project in Proteus software. So just we need to open Proteus software. So open it. In this project, just we will see the output of Arduino according to ultrasonic sensor in our serial monitor provided by Arduino IDE software. So just we required a Arduino board and ultrasonic sensor. So just keep with you and just we will make circuit diagram in Proteus software and demonstrate our project on hardware basis. So just keep along with you Arduino board and ultrasonic sensor. So let's start making connections. We require two components. First Arduino board, second ultrasonic sensor. So just move in component mode and click on pick devices. Search here for Arduino board. So type here Arduino. You will get multiple boards based on Arduino. So just here you have to choose Arduino Uno R3 model. So click on OK and it will get added to your devices list. Second, just we need ultrasonic sensor. So type here ultrasonic and you will get here multiple options for that. Just here you have to choose SCSHCSR04. So click on OK and it will add it to your device list. Now just click on Arduino board and drop it in your workspace area and rotate it clockwise. Second, we required ultrasonic sensor, so double click on that and place it in your workspace area. Now we require to connect our ultrasonic sensor with Arduino board. Before that, let's understand how ultrasonic sensor works. In ultrasonic sensor you will get two devices. One is ultrasonic wave transmitter and second is ultrasonic wave receiver. So when ultrasonic sensor releases ultrasonic wave and this wave when collide with any object in front of sensor, then the signal reflect from object and received by receiver. And just we need a calculator, means in programming portion just we need to calculate distance traveled by sensor, or you can say wave, and according to that just we need to measure the distance. So here you will get 4 points on your ultrasonic sensor. First one is 5-volt supply, second one is trigger pin, third one is echo pin, and the last fourth is ground pin. So we need to just connect our ultrasonic sensor with Arduino board. Connect 5-volt pin with 5-volt supply of Arduino. On your Arduino board, 5-volt supply is provided by VCC pin, as you can see here, and connect negative, that is ground, with your ground of Arduino. As you can see, this is connected. Now it's turn to connect trigger pin and echo pin. So we will connect trigger pin with pin number 2 of Arduino and echo pin with pin number 3 of Arduino. So it's connected. Now what you have to do, just you have to do the same connection on your Arduino board. As you can see here, this is Arduino board, and according to circuit diagram mentioned in Proteus software, just you have to make the same connection diagram on your hardware level basis. So just let's start the connection in your hardware. Here you can see this is ultrasonic sensor. As in Proteus software, you saw that there are 4 pins. In ultrasonic sensor also there is 4 pins. So it's turn to make connection with Arduino board. To connect our ultrasonic sensor with Arduino board, we required some jumper pin. This is male to female jumper pins. You required 4 of these. So let's make connection. Here you can see connection is completed as mentioned in Proteus software. So now we will connect this sensor with Arduino. Here you can see the connection is completed as shown in Proteus software. We have made the same connection. Now it's turn to complete our coding portion. For that purpose, just we need to open Arduino IDE software. So open Arduino IDE software in your PC. It's open now. Just we will write a code for our Arduino. Here, as we discussed earlier, there are 4 pins to program. In the 4 pins, 2 pins are for power supply and rest 2 pins are trigger and echo pin. So here we need to program trigger and echo pin. So first define trigger and echo pin here. Trigger pin we have connected on pin number 2, as you can see in your Proteus software. So we will just write here trigger pin on pin number 2. Next we will define echo pin. And we have connected echo pin on pin number 3, as you can see in your Proteus software. So we will write here pin 3. So declaration of the pin is completed. Now move in void setup function. Here just we need to configure echo and trigger pin. So we will just define here pin configuration for echo and trigger pin with the help of pin mode keyword. Here we need to provide a signal to trigger of ultrasonic sensor. So the trigger is output pin for our Arduino. So we will just define here output. And echo pin is input pin to read signal from ultrasonic sensor. So we will write here trigger echo pin as input pin. So we need to define here echo pin as input. Now we need to move in while loop function. So we will write here while loop. here what is the flow of our program. When our trigger pin get output means it will get supply from Arduino board. It will just release a 40 kilohertz signal ultrasonic wave from transmitter, and when we will make echo pin as high, so what will happen, just it will read a signal transmitted by our ultrasonic transmitter. So first we need to just write here trigger pin low for 2 milliseconds. So we will just write here first of all we need to make trigger pin low. So we will write here trigger low, and we need to provide here a delay of 2 microseconds. So we will write here delay we will just write here delay in microseconds. Just we need to provide a delay in microsecond. So we need to provide microsecond delay of 2 microsecond. So we will just write 2 in the bracket, and just we will end our command with semicolon. Now just we will make trigger pin high for 10 microsecond. So we need to write here digital write we want trigger pin high for 10 microsecond. So we need to provide here a delay of 10 microsecond. Now after 10 microsecond, just we want trigger pin should be low. So we will just write here we had made trigger pin high for 10 microsecond. After 10 microsecond the trigger pin should be low. So we have right here trigger pin low. Now what we have to do, just we want to receive the signal transmitted by ultrasonic transmitter. For that purpose just we need to write here when the signal transmitted by transmitter is received by receiver, then the receiver pin become high, means echo pin will become high. For that purpose just we need to read the time duration for that after the signal transmitted and when the signal is received by receiver. So just we need to calculate the time between transmitted signal and received signal. So for that purpose we need a variable to store the time calculated by signal. So for that we need to define an variable. We will write here duration for that. So we have created a variable. So here we need to tell the type of variable. So the variable is of long type. So we will define here long for duration. Now here just we need to calculate the duration taken by signal between transmission and receiver of the signal. So we need to declare here here is a keyword we will use pulse in. What pulse in function will do? Just it will monitor the echo pin till it becomes high, when it will receive the signal transmitted by transmitter, and when it is received by receiver, then it just echo pin will become high. So Arduino will just come to know with the keyword pulse in. So we will just write here pulse in. This keyword just will monitor the echo pin to be high. So we will write here here we have calculated the duration of signal processing. So now it's turn to calculate distance. So first of all we will create another variable of integer type for distance. So we have created here another variable named distance. So as we know, what is the formula for distance? Distance equal to time into speed. So we will use here the same formula. Distance equal to, what is the time in this program? Time we have calculated in duration variable. So we will write here duration into speed of the ultrasonic wave in the sound in the air. So what is the speed of ultrasonic wave in air? So we will multiply the time duration with the speed of ultrasonic wave in the air. So this is the speed of ultrasonic wave in air, and from this formula just we will get the distance between object and sensor multiplied by 2, because once the signal is reaching to the object and it just get revert back to the sensor, so it travel the same distance 2 times. So just we need to divide the distance by 2. So now we will get the exact distance between object and sensor. So we have just calculated the distance. Now it's turn to print the distance in serial monitor. So for that purpose just we need to initialize serial begin. So we will just use serial begin with the baud rate of 9600. So configuration for serial monitor is done. Now it's turn to print the distance in serial monitor. So we will just write here just we need to print the value of distance. So in the bracket just we will write distance. So we have calculated the value of distance in centimeter. So just we need to print the unit also. So we will write here centimeter. Now our programming is completed for ultrasonic sensor. Just we need to upload the code in our hardware design. So for that purpose we need a data cable, as you can see on the screen. So connect data cable with Arduino board. Now it's connected, as you can see. So it's turn to connect our Arduino board with laptop or PC. So board is connected now. Now you have to move in tool section and choose here for Arduino in board option. So choose Arduino Uno and again move in tools section and go to the port, select the communication port for your Arduino and upload the code to your board. As you can see, it will ask to save the code. So type here ultrasonic sensor and save the code. And now it will start to upload the code in your Arduino board. Before that, just it will compile, and as you can see the code is uploaded in your Arduino board. So the code is uploaded successfully. Now we will just see our output in serial monitor. So this is ultrasonic sensor. Now open serial monitor in your Arduino IDE software. You can see here your distance is measured by ultrasonic sensor and the unit of distance is centimeter. So let's check the distance with your hand. As you can see, the distance is varying with your hand's position. So it is measuring the distance of your hand with respect to sensor. As we move the hands near to sensor, the distance is decreasing, and apart from sensor, when we move our hands, the distance is increasing. So our project is working very fine. Thank you.